Okay, so for this part, I already did the Gaussian elimination and it gave me this problem. And as you can see, this problem ends up having a row that turns out to be 0 on both sides. So 0 equals 0. It just means that the system that you're dealing with has many, many solutions. So in the past, we would say that the two lines are overlapping. But in this case, these are not lines. These are like three-dimensional objects. They actually look more like papers floating in space. So having 0 equal to 0 just means that some of the papers are touching in a funny way. So some of the papers are going to be kind of like touching either by being overlapping or somehow by being crossing each other at a straight line. So that's kind of the idea behind getting a 0 equal to 0. The bottom line for you, it just means that there's more work. Now, if you did not get this in your Gaussian elimination, the first two equations could be random. They could be different numbers because the process of Gaussian elimination gives different kinds of solutions. It's not always unique. But what we will get, whether you do it or me, I'm going to get 0 equal to 0, and you're going to get 0 equal to 0 in your Gaussian elimination. So no matter what, that 0 equal to 0 is going to show up. The numbers on the other two equations could be slightly different, but the 0 equal to 0 will be there if you're doing it right. So you can try out your Gaussian elimination on this problem and see if you get that answer. If not, then you are doing something wrong. At least there should be 0, 0 on one of the equations. Now, how do you write down the answer in that case? What do you do to write down the solution of this system? Since we don't know what z is, what we're going to do is basically grab the second equation, which says 5y plus 2z equals to 18, and we're going to isolate the letter y by itself. So we're going to try to get the y by itself by first removing the 2z and then dividing by 5. So in this case, what we're saying is that the y depends on the number you choose for z. So pick the number that you want for z, and this is the recipe to get the y. You just multiply the number by 2, get some 18 next to it, divide by 5, and you get your y. Now, that gives us the y, but it doesn't give us the x. So we're going to try to find the x next. So to find the x, we're going to use the first equation, which is 3x minus 2y plus 1z equals to 1. And again, the goal is to get the x out. We want to know what x is. So we're going to start by first replacing the y with all the numbers that we got already from the other side. So we got y, and y turned out to be 18 minus 2z divided by 5. We're going to go ahead and grab all those things and put them in place of the y. So let's do that. So 18 minus 2z all divided by 5. And we're going to add, subtract, multiply. We'll do whatever we got to do until the x is by itself. So in this case, 2 times 18 is going to be, 36. Negative 2 times negative 2 is going to be negative 4. Positive 4 when you take care of the negatives. And then everything is divided by 5. So let's do that. I'm going to do each one of them by itself. 2 times 18 is going to be negative 36 over 5. I'm going to do negative 2 times negative 2, which is going to make positive 4 over 5z plus the 1z that was already there. Okay, I need x by itself. So let's get x by itself by moving all of these things to the opposite side. Now, keep in mind that these two are like terms. So I can add them before moving them, or I can add them after moving them. I'm going to go ahead and add them first. So 1 plus 4/5 is going to be at the end 9/5. So that's what I did to get the 9/5. I just added those numbers, and ultimately I want x by itself, so I'm going to move everyone away. So I'm going to have the one that's already there. I'm going to bring the 36 over 5 to it, and I'm bring the negative 9/5 z to it. Now these two become like terms, so I'm going to have to try to add them. 1 plus 36 over 5 is the same thing as 41 over 5. Again, calculators can do these things for you, so don't waste your time trying to do it by hand. 9/5 z. Finally, we want to divide each one of those numbers by 3. Again, calculator takes care of that very quickly for you. So we get 41 over 15 minus 3 over 5 z. So that's the answer for the value x. Okay, so now to write down the solution. So how do you write the solution? In the past, we would write 3 numbers with parentheses and then we would finish. This time though, it's a little bit different. So it's gonna be three numbers, except the first number is gonna be the x, which is 41 over 15 minus 3 over 5z. So that's, you know, what goes in place of the x, and then we're gonna put a comma. Put the number for the y. Well, there's no number, but it's 18 minus 2z, all divided by 5, which by the way is the same thing as 18 over 5 minus 2 over 5z, and that's how I got this to turn into that when I multiplied it by -2. So it doesn't matter really how you write it, just you can write it as separate fractions or one fraction, it's up to you. Then finally the third number is z, but we don't know what z is, so we're gonna leave it as the letter z. So that's how you're gonna write down your solution. This just means that your system is dependent. That's what it means to have 0 equal to 0, right? So the word is dependent. So having 0 equal to 0 tells me that my system is dependent, which means the solution is gonna be a little bit funky looking. You're gonna have to determine the letter y and the letter x in terms of the letter z.